right? So I'm going to install this. This one is called Dino Light, and so it's called Dino Capture. So for this microscope, yeah, you can buy this separately from this company. It's not from the probe station. They just integrate to theirs. Yeah. So if you want to use for anything, you can do that. That's that. Yeah. So you start this software. Okay. I need to connect it to here, right, to the USB. Sorry. Okay, and then the light is on, right? So do you see this? Here is the hole, the very hole, right? And let's see. This is for focusing. That is sharp, right? And then this is for polarizer. And where is this amplification? If I is this too low? Right? If I turn it on, you can feel that it is there. Okay. Now, how about let me bring the chip here, then you can take a look. Now I need to. I actually am very worried. Will we be able to probe it? Right. It's difficult to probe. Very difficult. So I might need to be in the class. Now, can you see it better? Yeah. So I would like to. Which one is which? Okay, I need to rotate 90 degree, just because of my layout. The way, the, right? I'm not able to put on the hole. Right, a little bit. Oh, I also have some problem with this one actually. You see the where's the hole? No, it's so it should not be mirror actually. So I've been wrong. Now it should be this. Now looks correct, right? So now I go to left. Yes. I go to up.
Yeah,
Yes,
yeah,
yes,
that's
yes.
right.
So I might need to even I even don't know which one is. Okay, you see it has two holes. This can add a larger die, but we don't have to, so we're not going to do this hole. I go turn this off.
Okay.
Okay, but we need this hole. Okay, so you're supposed to
Yeah.
stick it
Yeah.
now.
Yeah.
I really don't know if this is working. Yeah.
So the
Right.
orientation of the chip, like it's the black mark, one of the markers for orientation or something.
Okay, I'm going to. No, this is just the pad. Let me show you. In a real integrated circuit, you only have this square pad around the edge, and then you bond the wire to it and then to the package, right? But here we are not bonding. What we are doing is just that we have this pad, and later we're going to put a probe tip and touch them. Now you are not able to see what is underneath because all the transistors are at the bottom layer, gate oxide, and on top of that, you have maybe 9 layers of metal. And between each metal, you have the insulation. The metal are just the routing, just like the wire, the breadboard wire you did in the lab, right? But now you use some wire, just you put everything on the chip. Particularly here, you see I have an inductor, right? This is not for this class. This is for research. This inductor is actually some ring. You cannot see clearly. Some ring of metal. We just draw a spiral, not ring, a spiral of metal, and it becomes an inductor. Okay. This is the device we're testing. Why I know this is the one? Because I can see a big pad. This is actually the resistor. So this is something I want to show you in the class that for a semiconductor chip, you actually don't want to have a resistor because this resistor is only hundreds of kilo ohm or about 100 kilo ohm. You see, it occupies so much area. Think about this whole thing, right? Is 6,000, although you have 100 die. So this one is occupying maybe 1/20th of the area. So that is a lot of money, right? And imagine if you want to make a common source amplifier, you don't want to use the resistor as the load, right? Remember the RD, GM RD? That's why you want to add a PMOS. Remember, bias the PMOS as the active load, right? Then it becomes GM ROP parallel RON, right? And for that one, it is going to be very small. Here, you don't see it because the transistor, the NMOS, is actually very tiny, much smaller than this one, right? Before this class, you are going to do layout for this. You will appreciate how big the difference it is. Okay, so that is one thing, right? So we have set up these things. I even don't know if the vacuum is really working, but because I can move it, but that's okay.
So,
Yeah.
Professor, only the brown spot you're talking about is the transistor. What about the
No,
other
no.
ones?
Even the brown, yeah, okay, you are right. Under the bronze, you are talking about this region, right?
Yeah.
Under this, we actually put the transistor. But this is a test chip. I make very big transistor. This is like 100 micron by 100 micron. You don't do this in real case. Okay. For example, I have a transistor here. You don't see it because you don't have the pad, and I know that is under this region, right? I should actually just use the mouse. And then I have a gate, source, drain, body contact to it. So I can measure this transistor. It's the same as the discrete component you have in the lab. But in that discrete component, they already cut this and then bond this to the wire. That's why you can touch it as a human, right? Here you cannot, right? You see it's so small. Yeah. So this is about 75 micron. This is 1 millimeter by 1 millimeter. Okay, and of course, I draw it very large. Although this is 65 nanometer, it can be much smaller. But you can imagine, for 40 nanometer technology, for 7 nanometer, right, or even 3 nanometer. Of course, they don't scale accordingly. 3 nanometer doesn't mean that the gate length is 3 nanometer, but it is super dense. Okay, this one you really need skill, right? When I do the probe statement, I broke many probe tips. It's very normal. Yeah. You will do something very stupid. For example, I did not leave the probe tip and start moving the stage, and then they will scratch, right? You also damage your chip. I broke many, right? So that is what expected. Right? So I try to move gradually and then I feel it, right?
Yeah,
You see
I can
that?
see
And
it.
then I'm not going to move it. I use this put this back. Right? You can see that.
Yeah.
Now it's out of focus. I will go lower slowly. Right? Slowly, slowly, slowly. Slow, you need to have a feeling, you know it's going down, right? And this one help you to move left and right. Now for this chip, let me think. I can put in, I even don't know where's the source and drain, but I have capacitor, so I mean now it's a bad practice because I did not initialize the voltage to ground. It can be in 1000 volt, right? Static, right? So you can break it, but that is fine because my structure, I don't have anything connected to the gate directly. Fine for now because I just want to do the demonstration. So let me try to go down. I just try to touch one of the pad. Right. It's very difficult actually because the pad size is not large. So let's say my goal is to go to the top one. Okay, this top one. This one is the one I want to touch, for example, right? Or maybe no, because I have 4 probe, it coming from 4 direction. This one, the best is to touch the bottom one, actually, right? So let me just go to the bottom one. Okay, and this software allow you to do some magnification. How do you do magnification? Which one? This one? Thank you. Got stuck. Right? So if the software is not working, do not move the tip because it's not reflecting what's going on, right? And then you may crash. Okay, now I come here and then what? Okay, this 4 times, 6 times, I can go to 8 times here, right? That might be, do you see that? I zoom into here. It can help me a little bit to feel where it is. Right? It won't be exact because the magnification is not good. Now, so how do you do the probe? You keep going down and touch. You see it's live? Once it's live, it means it's touch, right? If you want to make sure that it has a good contact, you can pull it back, right? Just think about it. Go down, it's live. Then you pull back and go down again, slide more, right? But you don't want to do too much. You may break the tip.
Yeah.
Now, let me slide back and you should see a scratch. You said it scratch it. Yeah. And then I usually do a little bit more. And then I'm sure it has a pretty good contact for now, for this one, right? And then you do some testing. Now, I can tell you in the past, I was so nervous. I actually do a lot. And eventually, I broke the tip. Yeah. Yeah, then if it's moving, do the other first. And then you have 4 of them together. I think, hold on, I think it is pretty close already. We did not pull it.
Yeah, it's in the
Yeah,
top.
make it down. Yeah, don't pull it again. Yeah, and then usually what you will do is also make sure they are all tight. Do it one more time for all of them.
Down.
Right? Yeah, down. You will see that you should push forward. Okay, and then you know it's good because you're pushing the die, and then push this one. Right? Yeah, and then okay. You should not have this because of vacuum. That's why we have this problem. No, you should push down.
I'm doing that. Yeah, it's moving. Like, adjust this one.
Push it down.
Yeah,
Why?
the angle problem, I guess. I'm pushing.
Don't push sideways. Just push down.
It's the angle problem, I guess. Like when I'm
Okay.
putting, it's in the right angle.
Okay.
I'll try to adjust that.
Yeah, great. So now you know what to tell the student, right?